So Lewis ones, remember you're only drawing the valence electrons. So however it worked for you to draw those Lewis diagrams before, whether it was subtracting 2 and then 8 from their number of electrons to see what's left for the outer shell, or whether it is looking at the number at the top of the column and using the second digit, whatever works for you, keep doing that, okay? So to do ionic compounds with Lewis, it's pretty simple. Let's do sodium chloride, NaCl. So we look at sodium and see that it has 11 electrons, which means just 1 in its outside shell. And chlorine, we look at chlorine and see that it has 17. So we can do 17 minus 2 minus 8 and get 7. Or you can also see that it's in group 17. 1, 2, 3, 4, 5, 6, 7. So I think that you know where this is going by now. This electron moves over here to the chlorine. And now we have a positive sodium ion and a negative chlorine ion. Ta-da! That's it. That's faster, right? And I think easier. Let's try, before we did magnesium chloride, which has 2 chlorines. Magnesium, we look and see, okay, it has 12 electrons, so 2 in the outside shell. Chlorine has 7. I drew it over there. I should have picked a different one. That's okay. 3, 4, 5, 6, 7. Okay. Oh. Sorry for that bad noise. So I'm moving this electron over here. Chlorine is now a -1 ion. And of course, we need another chlorine over here to take that extra electron from magnesium. So this magnesium's electron moves over here. This is another negative ion. And this is a +2 ion. Now, I haven't drawn magnesium chloride because the chlorine is attracted to the magnesium. Remember how ionic compounds are held together by electrostatic attraction? So the chlorine, did you see that catch? The chlorine, the negative chlorine, is attracted to the positive charge of the magnesium. It's not attracted to the other chlorine. So I draw magnesium in the middle with chlorine on either side so that you can see that the chlorines are being held to the magnesium. The chlorines are not stuck to each other. Okay, they're stuck to that magnesium. So this gives us some hints about the structure. Okay, let's move to covalent. Covalent compounds are much easier to draw in a Lewis diagram, in my opinion. Covalent. So, first one we drew was fluorine. 1, 2, 3, 4, 5. I'm going to go this way so that the electron is left over here. You'll notice I don't use brackets when I'm doing covalent compounds. That's because no ions are formed. These are stuck together sharing electrons, so there isn't a different charge. They're not ions. They're atoms stuck together in a molecule. Okay, so now you can see that this fluorine wants to share an electron with its neighbor. So the way we show that is actually just a line. That's it. This line means there are 2 electrons there. There's special names for these electrons, actually, in covalent molecules. The ones that are not involved in bonding are called lone pairs. Oh, that's 2. I forgot. Okay, lone pair. The ones that are involved in bonding are called valence electrons are all of these electrons in the outside shell. These are called a bonding pair. Okay, let's try with water, H2O. Oxygen has 1, 2, 3, 4, 5, 6 electrons around it. Hydrogen has just 1. So these are going to share like that. These are going to share like that. And you can draw it in any configuration for now. You'll learn a little bit more about the 3D structures in Chem 11. So you can draw it with the hydrogens coming off like that. You can draw it with the hydrogens coming off on either side. Both are fine. You do need to remember that there are lone pairs here, because now if you count around the oxygen how many electrons are there to make sure it's stable, you've got 1, 2, 3, 4, and then each line is 2, 5, 6, 7, 8. Okay, so you've got to make sure you still have a full shell of electrons. Okay, last one I'm going to show you is sulfur oxide. Actually, sulfur monoxide, as you'll learn when we get to naming in lesson 4. So here's sulfur, 1, 2, 3, 4. I'm going to draw it this way, 5, 6. Okay, here's oxygen, 1, 2, 3, 4, 5, 6. Okay, now these form a double bond. They share 2 pairs of electrons, or 4 electrons total. And what that looks like is just 2 lines. That's it. Easy. These lone pairs, they can go like this, top and bottom, or they can go like this. It's not really a big deal for our purposes right now. Chem 11, you'll learn a little bit more about structure. Okay, I hope that's helpful. You can also make triple bonds. You can even make quadruple bonds. Okay, you just have to figure out how many electrons does each atom need to have its stable outside shell, usually 8 or 2 if it's hydrogen, or and it only has 1 shell. Okay, I hope that's helpful. Give the assignment a try and let me know if you have any questions or problems. Have a good one. Good luck.